So 3y and 8y, 11y. And then negative 9z and 6z is negative 3z. And then 0 and negative 14 is negative 14. And I can take this answer and I can replace either the first one or the second one with that answer. So I'm going to do the second one, right? Everyone okay with that? So I'm going to rewrite the whole system of equations again. Okay, the whole system of equations. Now I want you to tell me what, what the heck? Wait a minute. Hold on a second. That first one, hold on, that first equation up here, we multiplied by what to get this?
2, 3. Negative. No, positive.
Oh, 3.
We multiplied by 3? Okay, I apologize.
So it's 2x plus y minus 3z.
That's the original. Quick question, why is that not a 21?
We did the first equation and third equation?
Oh, right.
0 and negative 14?
And then
11y minus 3z equals negative 14. Okay, now I did something very subtly there, which I didn't have to do, was not required. This was 6x plus 3y minus 9z equals 0. And I took it back to what it was originally, which really just means I multiplied this by 1/3, and I took it back. I'm allowed to do that. I divided by 3, right? I'm allowed to do that because I only multiplied it by 3 to get those two equations to cancel. Once I've done that, you can actually go back to the original. So do y'all understand? You could have put here 6x plus 3y minus 9z equals 0, and you would still get the same answer that I would get. But if you don't want to make a mistake, or if you want to kind of keep your numbers small, you go back. All right? Optional step.
Just because the only ones we wanted to change were those two.
That's right.
so then get rid of the y.
Yeah, there's only one more thing to get rid of, right? And I'm almost there, right? I just need to get rid of this y right here. So I have some choices. Go ahead.
Would you like multiply a number by all three?
Yeah, so I'm always going to want to work with just two equations at one time. But I could work with the first one and the third one, or the second one and the third one. Second and third is the one that I am going to do, okay? These two. Now, this is not going to be a very nice thing that we're going to multiply by, but that's right. This is the way it is. So how am I going to get 3y and 11y to cancel? 11 and negative 3, or you could have done negative 11 and positive 3. Either way, we'll all get the same thing. That'll give us 33y on the top one and a negative 33y on the bottom. Rewrite the whole damn thing. Now, the next chapter, or the next section, which has already been kind of hinted to, is called matrices. And matrices is just a shorter notation for everything we're doing right now. We just basically have to work with the numbers. We don't need all the letters in there. And so it makes it a little faster, a little more compact, but it's everything we're doing right now. All right, so what does my second equation become? 33y minus 22z equals negative 77. Negative 33y plus 9z equals 42. I would agree with you if you said that there's a lot of room for error here. You know, like just little computation sign things. It's just the nature of the beast. That's the way it works. All right, so now what I'm allowed to do is take any two rows that I have and add them together. So I'm going to add the second and third row together. And that'll give me an answer. And that answer, I can replace any row with that answer. So go ahead and add the second and third together and tell me what you get.
Negative 13z is equal to negative 35.
Anyone else get that? Yes? That's your second and third row added together. The y's go away. Your z's.
Equals 35 over
So z is 35/13. All right, now, I could box that, couldn't I?
Yeah. So you finally got one variable by itself.
I did, so I'm just going to kind of be complete here, and I'm going to,
But write all that stuff back.
yeah, just to be complete, okay? That's all I'm doing. So I'm going to rewrite where,
2x plus
Plus
y
y minus 3z.
yeah, I'm going to go back to this one, look. I'm going to take my 33y one right here, I'm going to go back to this one, because it's cleaner to work with,
Because you can do that.
and I'm allowed to do that. And I'm going to let this last equation become z equals 35/13. And that's my system, and I now have it triangulated like I told you. I've got this empty, right, that empty boxes there. And everything is back substitution now. You think you could take it the rest of the way?
I can see why in the first time that you wrote that you wanted to keep it triangle now.
I'm just going to tell you what the answers to this are, okay? I'm going to let you, on your own time, go back and do this. You should get y is equal to -7/13, and you should get x is equal to 56/13. And of course, z we already knew was 35/13. So you would write that as an ordered, we call this an ordered triple, not an ordered pair. Ordered pair is when it's just x and y. Ordered triple is when it's x, y, z. 56/13, -7/13, and 35/13. All right. Y'all doing all right?
I can, yeah. Just interesting concept to understand that you can replace those at any time.
Yep. All right. The beauty of elimination is that now if I gave you 4 equations with 4 variables, you could do the same thing and create a triangle and work your way back up again. 5 equations, 5 unknowns, same thing. In fact, one of the first computer programmers, back when computers were first coming around, one of the first computer scientists to earn like a major prize, like almost like a Nobel Prize, was a computer scientist who was doing, I believe, some work on like weather. And in the problem, he had to solve a system of equations. It was 60 equations and 60 variables. And he used a computer, and he wrote an algorithm which does Gaussian elimination. And so it would go through and it would compare things, and it would look at, I want to kill the x off and multiply and scale and replace. And it's an algorithm. Okay, can you imagine that a computer could probably do this? Right? It's just manipulations of numbers. What's that? A lot quicker, especially when you get 60 variables and 60 unknowns. When I was in, I think my senior year of college, I had to write an algorithm to do this and code it up in C++. It was, I don't know if fun is the right word to describe that. It's probably more like suffering. But the point is that it's a very powerful method, and we use it all the time. Computers are used to do this. Now, your calculators do it. Let's take a little poll here. Those of you who have calculators, how many of you have like a TI calculator, Texas Instrument? Who does not have a TI? Try it if you don't. What do you have? You just have a basic function calculator? Okay. Anyone else just have basic function? Everyone else is a TI? What's your major?
Mine?
Mhm.
Engineering.
Engineering? Go get yourself a TI. It's time.
It's done.
It's time, yeah. All right. Because like in my Cal 2 classes, we do something where we get to systems of equations, and sometimes it's 2 and 2, which you can do with elimination or substitution, or it'll be a 3 by 3, which is this. And in the Cal class, I don't solve the system of equations. I just say, oh, and if you solve this, you get this. If you don't have a calculator, then you're going to do it by hand. That's going to take you forever. if you have a TI, it has a function that allows you to do this, all right, which I will show you all after next class, or at the end of next class, because we'll talk about matrices, and then you'll see how to put the matrix into your calculator, and then the calculator will do the computation for you, and it's beautiful, all right? I'll teach you that later, though, okay? Now, if you don't have one, that's okay. I'm not telling you you have to go buy a calculator by your next class. Just my advice for someone in that field, go ahead and get yourself one. Learn how to use it. It'll serve you well. Okay. Let's do a word problem. You've got to practice with these, right? I mean, that's obvious that you're just going to have to practice a couple of these. Your homework will give you that opportunity. There's some in your homework that are a little different than what I put up here. Let me see if I can tell you specifically. Like in your homework, this problem number 43. I'm not going to do the problem. I just want you to see it and we'll talk about it. Here's a problem straight out of your homework, number 43. This does not have that triangular shape to it, does it? No? If I was trying to get it into that triangular shape, I could rearrange it. Is that right? And then x. I didn't have to put that one on top, I guess. Doesn't matter what order I put this in.
It's going to be kind of fun.
2y plus z equals 4. That's the same thing, right? I just rearranged them. I can try and now kill off this x by multiplying by, what, negative 2 here. Then adding down, that would kill that off. And then you just continue and try and work through it. Understand? You could have put this one on top of that one, those two.
Is it okay to like leave boxes as placeholders, or
If you want.
for our
Yeah, if you want, sure. All right, now I'm going to do a word problem. And to get this, to motivate this word problem, I'm going to see if you remember the idea that if somebody gives you 2 points, there is only one line that goes through those 2 points. Do you agree? Once 2 points are given on a flat sheet of paper, there is only one line through those 2 points. Yeah? And if someone actually told you what the points were, like let's say they told you this was the point 1, 2, this was the point 5, 7, I could actually ask you right now for the equation of that line, couldn't I? And so what you would do is you would go find the slope first, right, m. So you'd figure out what your rise over run is. The formula for that, if you don't remember, is y2 minus y1 over x2 minus x1. That ring a bell? So this would be 7 minus 2 over 5 minus 1, which would be 5/4, right? That would be your slope. So you'd be able to say, all right, y is equal to 5/4 x plus b. That's what you would know so far, right? Go with me? Then the only thing left to do is to figure out what b is. So I use the fact that I have a point here, right? And I know that when I plug this in for x, this comes out for y. So if I come to this equation, I replace the y with 2. I replace the x with 1. Then it should be true, right? Y is 2, x is 1. And now I can solve this for b. Once I know what b is, I come back up here, put it right there. That's the equation of the line. This kind of looks familiar? The point is that if someone gives you 2 points, there's only one line, and you can come up with the equation of that line if need be. How about if I said, here are 2 points. Is there only one parabola that goes through those 2 points? No, right? You could draw a bunch of different parabolas that go through those 2 points. You could draw one that looks like this. Maybe that's the highest point. You could draw another parabola that looks like this. I could be here all day long, right? Drawing parabolas that pass through those 2 points. So giving someone 2 points is not quite enough to determine uniquely what parabola goes through there. How many points do you think you need? 3. Turns out that you need just 3 points. If you give me 3 points, there's only one parabola, only one that goes through the 3. And I'm going to show you kind of a rough proof of why. It's not a proof because it's going to be an example. But in this example, I hope I can convince you that that's all you need is 3 points. All right? So I'm going to go ahead and just write 3 arbitrary points up here. I'm just going to make them up right now. I want you to find the equation of the parabola through these points. 1, 3, 4, 10, and -1, -5. Now I know already that this is going to be very ugly because I'm making the problem up, so our numbers will not be nice, all right? So let's now just think about what it is that we're trying to find, the equation of a parabola. What does the equation of a parabola look like? Y equals x squared. That's just your basic parabola. Does anyone remember?
Plus squared plus something or minus something.
Okay, there were 2 forms of a parabola. There was ax squared plus bx plus c, and then the other one was ax minus h squared plus k. Do you remember those 2 forms of parabolas?
Yes.
This was called standard form. This was called expanded form. We are not going to work with this one. We're going to work with this one right here.
Because that one's cheating because that will give you the vertex.
We don't know the vertex, though.
Right.
Right? We would use this if they gave us the vertex, right? If I told you, hey, but this point's the vertex, we would be in business, right? But I'm not telling you that any of those points are the vertex. Those are just points on the parabola. All right, so let's think about this. What does that first point, 1, 3, tell me?
That at x1,
At x is 1, y must be 3, right? So I'm going to write that down right here. For this point, 1, 3, here's what I know. I know that this y should be 3, and all these x's should be 1s. So that would give me 3 equals a times 1 squared plus b times 1 plus c. Agreed? I didn't need to write 1 squared because it's just 1, but
you're just filling
just doing it so you can see what I'm doing, right? This is really a plus b plus c equals 3. Agreed? I'm going to write it that way. A plus b plus c equals 3. That's what the first point tells me, right? By the way, this is a single equation, right?
Yeah.
How many variables? 3. I have 2 more points.
You can get 2 more.
So I'm going to be able to get 2 more equations. So in total, I'm going to have 3 equations with 3 variables, which is a system of equations, 3, and that's exactly what we just did, right? So what's the next point tell me? 410. Tells me that 10 comes out, right, when I plug in 4 for x. What is that equation when I write it out? 16a plus 4b plus c must be 10. And what does the last one tell me? What does the point -1, -5 tell me? -5 equals a times -1 squared plus b times -1 plus c, right? And just be careful when you square that -1, it becomes positive, right? A minus b plus c, right? Must be -5. There's your third equation. And I have 3 equations, 3 variables. I set up a system, right? I do my big brace on the left, and I write them out. Any questions on that? No? I'm going to go ahead and write it out. This is going to be 16a plus 4b plus c equals 10. And then it doesn't matter what order I write these in, right? Doesn't matter. I could have written this one first. I don't know why I did that, but it doesn't matter at the end of the day. There you go. All right. We good? Does everyone who has a TI calculator have them with them? Yes? Okay. I think I'm going to take this opportunity to show you how to use your calculator to do this. All right? Because I don't feel like solving that by hand. I'm sure you don't feel like solving that by hand. But you know what you would need to do, right?
On the test, you're going to make us do it by hand.
You know what? On the test, I probably will need to make sure you can do elimination at least on a 2x2. All right? 2 equations, 2 unknowns. On a 3x3,
That won't be too crazy.
I mean, something very basic, but I'd like to see you do it. But you could use your calculator to check your answer.
I think you can do it.
You can, yeah. All right, so let's see if I can teach you how to use your calculator. So everyone get your TIs out, all right?
Got mock calculator.
Now before I start this, I know that, especially in high schools these days, a lot of stuff is done on calculators. So I know that some of you already know how to put a matrix into your calculator. If you do, that's fine. I'm not here to change what you know. What I'm going to put on the board is what I know will work on any TI calculator, regardless of which version you have. So instead of inputting the matrix, I'm actually just going to call up the function that does the solution for us. All right? That's what I'm going to do. So on your calculator, you're going to go to what's going to be your math menu, or you might even have a menu on there that says matrix. So I want everyone to find that first. Where did you go there?
Would it be under catalog?
Matrix is right above that. You see that? So you have a matrix menu. Stay there.
I also have a main.
You have matrix is right in the yellow, so you have to hit the yellow button first.
I have math
You find yours?
and matrix.
Okay, so you're putting yours in that way.
Is that right? Is that right? Math.
Yeah, go ahead and hit enter. Okay, just stay there.
Because I have math and then I
Nope.
have matrix.
Matrix, that's the one you want. Did you find it? Steven, yes? Find yours? No, just go to, let me see. Where the hell is it? No, let me see this. This looks brand new. Okay, there it is. Quit. Okay, so right above the 5 in blue is math. So you hit the blue and then hit, and then go down to matrix to the right. Okay, stay right there. You found yours? Okay, so most of you are at a point right now where it says names, math, and edit or something like that, except you. You're not at that. You're not at that, right? You have, okay, you just stand still. You have names, math, edit across the top. Okay, for those of you who are at that names, math, edit, move to the right to edit. Wait, hold on, math, sorry. Math. and then scroll down. Now everyone should be able to scroll down and find something that says RREF. Everyone see it? Hit the enter key and it should spit you back to your home screen. And you should have RREF sitting there with the parenthesis just waiting for you to type something in. Do y'all see that? Anyone not there? Did I check yours? Yeah. You found it? So you went to your matrix menu, then you go to the math column, and then scroll down and go to RREF. Be careful to not use the one that says REF. There's RREF and there's REF.
What's the difference?
A lot. This stands for reduced row echelon form. The other one is just reduced echelon form. What this basically is saying is it's going to make the triangle for you. That's what that's. And not only that, it's going to do even more. You know how I was telling you I wanted you to get from like equation, blank space, blank space, blank space, and then like this? And then we could back substitute. That function RREF does even more than that. What it does is it puts blank space here, here, and here also. So all you have are numbers here, or sorry, you have your things in here. So automatically you know what Z is. Then this, there's no X, there's no Z. So it's telling you what Y is. It's basically solving it for you. All right.
Tells you what A, B, and C.
It's going to tell you exactly what your answers are. But, okay, that's what it was supposed to do, right? Okay, so now here's the rest of it. Okay, and this is where things get a little weird. What we're going to do is we're going to look at this system of equations in what's called its matrix form or its augmented matrix form, which is I'll talk more about next class. What we do is we rewrite it, but instead of using a brace, we use two sets of brackets like this. We put a dotted line like this. And then the numbers on this side right here, 10, 3, negative 5, are going to be listed here. 10, 3, negative 5. And then here, we're just going to look at the coefficients of A, B, and C. So what are the coefficients across that first row? 16, 4, and 1. So I'm going to put 16, 4, and 1. What are the coefficients for the next row? 1, 1, 1. So I put 1, 1, 1. And then I have the 3 over here, right? And then the last one, 1, negative 1, 1. Agreed? Here's what's going to happen. We are going to tell our calculator to do reduced row echelon form to that. I need to tell you still how to put that into your calculator. I still need to show that to you. But what your calculator is going to spit out when it's done is this. 1, 0, 0, 0, 1, 0, 0, 0, 1, a number here, a number here, and a number here. Why are these numbers your answer?
Because that's what it,
This first row now really represents what? 1 X, or in this case A, right? 1A, no B's, no C's, equals that number. The next row is saying, okay, no A's, B, 1B, no C's, B equals that number. And the last row is saying, no A's, no B's. Okay, C is equal to that number. Do you understand that? Okay, so how do you tell your calculator to do this? Well, you first bring up the function, which is what you did. And now we have to insert the matrix.
Siri, insert the matrix.
And this is where there's going to be some differences, because I know some of you already know how to put a matrix in. I do it a little different. Here's how it's done. You're going to find your bracket button. I think it's above the 7. Above the 8. Okay, you see the parenthesis? I think it's above the parenthesis. So you have to like do shift. Nope, that's a brace. Your bracket is above, I think yours is in green.
oh, it should be.
No, it's above your multiplication key. Everybody find their bracket? Okay, let me tell you what this first bracket is telling the calculator. Maybe I should back up. REF says this is a function I'm about to do, right? The parenthesis says, okay, everything past this is what I'm going to do this function on. This first bracket says start the matrix. That's what it's telling your calculator. This is the beginning of the matrix. Yes?
It needs to be the straight one, right?
Yes, not the brace. That's a brace, that's a bracket, that's a parenthesis. All right, start the matrix. Here we go. Then another bracket. What's that? Start the first row. That's letting your calculator know, here comes the first row. Start row 1. I always get students that know how to put a matrix into their calculator. They always get pissed off at me when I show them this, so please don't get upset. I'm trying to, again, give you something that's universal that'll work on all these calculators. All right, now I start putting in the numbers of the first row, which are 16, 4, 1, and 10. I will separate them with commas. 16, comma 4, comma 1, comma 10. The commas on your calculator above the...
I can't find it.
yeah, it's going to depend on... I think it's above the 7. Yeah. Everyone find their comma?
So we would just put the 10 as a comma.
10, and then close bracket. Bracket the other way. What is that telling your calculator? Ending the first row, right? End row 1. And then what? Bracket. So we call this an open bracket, no parenthesis between, just open bracket. And then that's the start of the second row. Put your whole second row in there. 1, comma 1, comma 1, comma 3. What? Close bracket, open
I
bracket?
still can't find my comma.
Right above the 7. It's got its own key.
Oh.
Yeah. Close bracket, end second row. Open bracket, start third row. 1, comma, negative 1, comma 1, comma, negative 5. Make sure you're using your negative key, not your minus key on the negatives. Y'all know there's a difference? Yes, okay.
And then 2.
And then close bracket. We'll close off the last row. Good. Then close bracket again closes off the matrix. And then close parenthesis closes off the function. Now I realize that that seems initially like a pain in the ass. But I've been doing it that way for years and years and years. And if you just pick up on the pattern here, then I've challenged people who know how to put matrices in on these, and I'm usually faster than them because it takes a little more. You have to define the matrix first, then you have to go back and call on it again, and it takes a little longer if you do it the other way. So, yeah. Enter. Okay, that means there's something wrong in the way you typed it in. Can you go back to it? Do you have an option to go back?
They gave it to me.
All right. Here, let me look at it.
This one's really cool. It even tells you the ref.
Yeah, on these.
I know. Hey, I bought this when these were
16, 4, comma, 10, 1,
They still are. What are you talking about?
1,
They are?
Yeah, they have not come down in price.
Oh.
Whoa, what the heck?
I saw one of the silver editions at Target for like $30. I got a deal on mine. Free? Well,
I cannot find your syntax error.
Wholesale, we're still buying.
Oh, I found it.
Okay.
Right after that one right there, there's no comma, where it's flashing. Okay, can everybody interpret their answer?
Yeah.
Now, there's also a button on your calculator, I'm not sure where it is, where you can convert decimals to fractions.
Yeah, there is some.
Does everyone know where that is? Can you try doing it right now?
I can just do it just by looking at it. Yeah, negative 1/3.
Okay, but if you couldn't, hold on, if you couldn't, try, just use the button.
Isn't it out?
I don't know, it depends on the calculator on this one.
Oh, I forgot I just did it not that long ago. Oh. Wait, no.
No, that called up the last answer.
Isn't it like second?
Did you find
back?
yours? You don't,
Back. All right, hit.
yeah. And did it do it? Oh, it did. Okay, can you give those to me, please? Hold on. You're just reading, you're reading down the right side column, right?
You want the decimal or the fraction?
Well, you can do either one, but I like, if you did this by hand, you would have fractions, right?
Yeah.
Okay, so on this,
Fractions, but then I.
yeah, just then use the fractions. You got 1/3, go ahead.
-1/3 or -2/3.
Whose calculator gave him something like that? Is that what you got? Now, your calculator doesn't show you the dotted line, okay? You have to understand that that right column are your answers. And remember, this is A, B, and C.
I know what it is,
So that means that y equals ax squared plus bx plus c is the parabola, right? And we now know what a, b, and c are. So it's -1/3 x squared plus 4x minus 2/3. That's the parabola. That parabola passes through those 3 points. See what I did? All right. Once you have the parabola, I mean, you could theoretically graph this, couldn't you? And we actually know that it opens down, right? We could find its vertex. We could find its x-intercepts, right? That's all fair game. Now, to give you a little bit of motivation as to how this could be used, let's say you've got a guy playing baseball. That's a bat, and there's a ball coming towards him. And he hits the ball, right? This is a Major League Baseball player. He hits the ball, and there's some fans up here, right? And the ball comes off his bat and hits into the crowd, right? And then later on, they tell you how far the ball went. And there's no way they could know because it hit the crowd. So like when they say how far it went, they aren't talking about where it hit the crowd. They're talking about how far it would have gone had it not hit the crowd. That's what they're telling you. So they're somehow figuring out where this point over here is, where it hits the ground. So here's how they can do it. If you look at this as being like, an XY axis, they can figure out what this point is because it's actually physically in the stands, right? They know how far away it was from him, and they know how high it was.
and they know where that other is.
They know where the ball came off the bat, right? They can measure that looking at a video or a still picture or something. And then what they do is they just have one other reference point, right? If they just have one other point, and that's what they do. They just focus on one point, and they use that as a reference. And if they calculate that one point, you now have 1, 2, 3 points. As soon as you have 3 points, you go into the calculator, you generate the function. Once you have the function, you set it equal to 0. That'll give you the x-intercepts. One of them is going to be this point, which will represent the distance from home plate or wherever he hit from. Understand? Okay. That's all for now. Try to do your homework for 12-1. Okay, that's the main thing to focus on. Homework for 12-1, and that's wrapping up the week, right? Tomorrow's a holiday, school holiday for Fiesta. So nobody's going to be here.